let's say that you've got this grandma that just like hooks you up, right? You have your bar mitzvah. Anyone know what a bar mitzvah is? You got your bar mitzvah and your grandma's like, bam, 20 G's, bam, lays it on the table and she's just like, this is for you, I love you, my little mushkin, you know? I don't know. So she loves you so much, she gives you $20,000 and you're just like, this is great, thank you, grandma. Like you are hooking me up right now, you're so excited. And you have this choice, because you're a young person, right? You have this choice, you're like, do I save this $20,000? Do I save it? Or do I buy myself a new car?
Oh, I am buying myself a car.
Okay? Do I save this $20,000 and invest it, or save it, whatever, or do I buy myself that brand new El Camino?
It's only 20 G's.
Yeah.
Ford Mustang.
Those are 24.
Nice. So what do I do? What do I do with this money? That's the question, right? Or do I just like buy myself like a nice bling Bitcoin, okay? So what do I do? That's my question. Okay? That's my question. That's a real life question potentially, maybe not for all of us. We don't always just get $20,000 from our grandma for our bar mitzvah, but just say you did. The question is, what do you do? Right? It may be very tempting to spend that $20,000 on a brand new car, but I think it would be good to explore the potential implications of that decision, right? Should we go for that today? I think that'd be fun, right? Okay, so let's explore that. Let's say that you go for option A, which is saving and investing, all right? Now, if I actually did some research over lunch, and I looked at all the different interest rates, and nowadays, if you put your money in a savings account, you get like 0.06% interest rate, so it's no use, really. You might as well just put it in a sock drawer or something, okay? Or even a CD, which used to be good, have high percentage, now is only like 1% or less, so that's a really low percentage. But the only thing really of lots of value to kind of get your money back is to invest in the stock market and something like that, or have investments in mutual funds or some kind of thing like that. You can have Roth IRAs, things like that have investments. Some are more safe, some are more risky. You guys, am I speaking language that you guys understand? Risky investments, safe investments, that kind of thing. But riskier investments can have higher percentage rate return. Less risky investments generally have a lower percentage rate return. And so just about in the middle there, I found about 7% interest rate return. Was a pretty right in the middle, that if you kind of, a little bit risky but kind of safe still, you can get 7% if you're smart about it, okay? So let's say you take your $20,000, you guys still with me? You take your $20,000 and you invest it in some kind of fund and you're getting a 7% interest rate return on your investment, okay? So you take your $20,000 and you're getting 7% back. Well, how do I figure out what 7% of 20,000 is? What do I do? Multiply by 0.07. So I do 20,000 times 0.07, right? I don't multiply it by 7. That wouldn't make sense, right? I multiply it by 0.07, right? And I figure out that 7% of $20,000 is $140. So that's cool. I just gained an extra. Oh wait, that's wrong. Sorry, that's not $140. It's $1,400. Sorry, let me just do my math real quick. Make sure. 20,000 times 0.07, 1,400. Cool. All right, $140. It's rough, right? So $1,400. Nice. That's cool. All right. Extra $1,400. Nice. 1 year investment. Cool. But you don't just end up with $1,400, right? You don't end up with $1,400. You still have your original $20,000, right? So at the end of the year, you have $21,400. Does that make sense to you guys? Okay. But I'm not just going to invest it for 1 year. I'm going to continue to invest it. And so I say, all right, I'm going to continue to invest my money. So the next year, I earn another 7%. Okay? But just like in the previous year, I don't just have my interest, I also have the starting amount. So I add that to 21,400, and I get 21,400 times 0.07. That's the interest I earn, plus the 21,400 that I originally had is 22,898. You guys still with me?
Yeah.
So at the end of 2 years, you have $22,898. That's pretty cool, right? Extra $3,000 just by investing, making smart investments. Does that make sense? Okay. Now, the cool thing is like, I could keep doing this, but like, we're mathematicians, right? And this seems kind of silly. What if this is 1 year, 2 years, okay, fine. But what if I wanted to figure out how much I'd have after 50 years, right? Would I have to keep doing this, like, same multiplication over and over? It seems like there's probably an easier way of figuring that out, right? How much money would I have at the end of 50 years? Does that make sense to you guys? So that's the point. That's what we're gonna walk towards right now. So how are we gonna get there? Well, let's start again with our initial investment. So we started with $20,000, and then to find 7% of that, we multiplied it by 0.07. But we have to add our original $20,000 to figure out how much money we'd have at the end. Does that make sense to you guys? So I started back again in my initial investment because I want to find a smarter way to do this. So I do that, and then I say, okay, well, before I just figure out what this equals, I want to simplify it. Okay? And one of the ways I can simplify is by finding a common factor of the two terms, right? What's the common factor of these two terms? What's the thing that they have in common? This is 20,000 times 0.07, and this is just 20,000. What's the common factor? 20,000. The common factor is 20,000. So I'm going to pull that out. You guys remember this from factoring? I pull out the common factor. I pull out 20,000, and I get left here with 0.07 plus this is just 1. Does that make sense to you guys? You see that? You see what I've done? So I'll simplify this to 20,000 times 1.07. Okay? Is that clear? You see? So that's actually easier. And if you take a look at this, this makes a lot of sense. Instead of finding 7% and then adding it to 20,000, if 0.07 is 7%, then what's 1.07? 107%, which is exactly the same thing as saying, oh, I earned 7% interest. Does that make sense to you guys? Is this clear? Okay. So instead of doing this whole thing, I just multiply by 1.07. It makes my life a whole lot easier, you see? And if I do that, I end up with 21,400, right? But then to get the second year, again, I would just multiply by the same thing, 1.07. Does that make sense? And I would end up with 22,898. Is that clear to you guys? Is that clear? Yeah? You guys with me? You guys with me still? Okay. So what am I doing for each year? What am I doing? What's my step? This year, what do? I multiply by 1.07. I multiply by 1.07. So in the first year, I multiply by 1.0. Guys, I need you guys to be engaged. I promise you this lesson becomes very boring if you're just like waiting for me. Okay? 20,000 times 1.07. Every year I multiply by 1.07. Is that clear? Is that clear? Okay. So why don't I just do that in one step? Look, the first year I multiplied by 1.07, but if I wanted 2 years, I just multiply twice by 1.07. You see? What if I wanted 5 years? How many times would I have to multiply by 1.07? 5 times. Can you say that again, Mr. Martinez? Say it again? Yes! But instead of multiplying by 5 times, I could just say 1.07 to the 5th, right?
Couldn't
And
you put 507, 5.07?
No. It's a fine guess. I see where you're coming from, but no. It's multiplying by 1.07, so it's not just adding each time. You understand? So I multiply by 1.07 5 times, so that's 1.07 to the 5th. You see? And now my life is way easier. So if I'm multiplying by 5 times, that's to the 5th power, so that's 5 years. What would I have to do if I wanted to figure out how it would be after 100 years? what changes? The 5 isn't still 5, it would be 100, you see? So instead of doing this process for every year, I just change that variable or that number and then bam, I've got my answer. You see? Is that pretty clear? Okay, so now let's explore this. So I want you guys all to let's say, okay, so I have 20,000 times 1.07 to the 5th, right? So let's figure out what that equals. 20,000 times 1.07 to the 5th. Hey, that's pretty cool. $28,051. So after 5 years, I'd have that much, right? Cool. So, do you guys have calculators with you? I meant to tell you that in class, sorry. Go, if you don't have your calculator with you, go get it now. Everyone pull out your calculators, please, because I want you guys to do this exploration with me. Okay, quick. Get your calculators. You can use, not right now. Okay, and the rest of you guys just use your calculators or pull out your computer, okay? Your computer, it can be used as a calculator too. Okay, just you can, okay. All right. So, this is how much money I would have at the end of 5 years. Okay? Now I want you guys all have calculators that are still in the room? Yes? Nice. Okay. I want you now to figure out what I would have at the end of 10 years. So go ahead and calculate that now. So remember, you have to use PEMDAS. You have to use PEMDAS. So parentheses first, but it's already done, but then exponents. So you do 1.07 to the 10th power, and then you multiply that by 20,000. So go ahead and calculate that now. Yep, sure. Mm-hmm. And you guys are going to need to start bringing your scientific calculators. Yep, good. So you guys are all going to have to start bringing them. And you're going to be able to use it on the next quiz. So obviously you're going to want to bring it. Welcome back. Thank you for coming with speed and vigor. Nice. Okay, so what I've asked everybody to calculate was 20,000 times 1.07 to the 10th power. And what do we get? $39,343. That's not bad. Hey, after 10 years, I pretty much doubled my money. Okay, so that's cool. So after 10 years, my 20,000 turned into 39,000. Okay, now before we go on, I just want to pause for a second, and I want to show you something. What if instead of my initial amount, 20,000, I said it was A, just the initial amount, and instead of 0.07, I said it was R, the investment rate that I have. okay? And instead of the time in years of just 10, I said that was t for my time in years. Well, what would my equation be? It would be a times 1 plus r to the t. You see? Does that make sense, guys? So, generally speaking, as in our case, your initial investment is fixed, right? You've got $20,000. That's not changing, right? Generally speaking, your R, your interest rate is fixed. In our case, we said it's 7%. So what's changing? What's the only thing that changes? T. T. So what's your variable? T is your variable. Okay, keep that in mind. Keep that in mind. Now let's continue. Go ahead and find the result, how much money you'll have at t equals 20, so 20 years. Go ahead and figure out.
Same question.
Same thing except your time is now 20. You guys following along? Okay, now remember, this is your grandma's money that she hooked you up with for your bar mitzvah. $77,394. Okay? I know, I rounded up. 1.07 to the 20. $77,394. Okay, and mind you, that's only 20 years later. You guys are what, 17, 18, some of you now, right? You're only you're not even 40 yet, and bam, you got $78,000 saved up. That's pretty solid, right? Thanks, Grandma. But let's take it a step further, okay? Let's say you're saving for your retirement, okay?
401k.
You're just putting it in your 401k. You're just going to let it sit there. You're saving it for your retirement, okay? So let's say t equals 50, because, 50 plus 18 or something, that's about 68. All right. Okay, you're an old man already. One math class, and you've just gained 5 decades. Okay, so figure out how much money you would have for your retirement. Now, mind you, you've saved this $20,000, which clearly is a significant amount of money, but you've just saved that up in a bank account at 7%, or not a bank account, in some mutual fund for 50 years. And let's see what you get. What do you got? You guys got some O's and some A's right there. $589,141. Okay. That's pretty cool, right? You're 20,000. Look, this is not smoke and mirrors, guys. This is math. All right? This is not a joke. This is what happens if you save $20,000 at 7% for 50 years. That $20,000 turns into $589,000. That's pretty cool. But now look at this. Let's say that you're not just saving for your retirement. You're thinking about the next generation. And you're like, when I pass on and I go be with Jesus, I want my kids to be good for their retirement. So I'm not going to save for 50 years. I'm saving for 70 years, okay? You're saving for 70 years, all right? So you guys are 88 years old now.
Most people barely live.
All right. But you live a nice long life, okay? Saving for 70 years, and then tell me, go ahead and see how much money you've got. I guess we don't even have to save. Let's save it for 60 years. Go ahead.
I already did 70.
You already did 70? Let's 70? Okay, 70 years. Let's do 70 years. Okay, it's a little too much? Okay. 1.07. So you've saved until you're on your deathbed 70 years to whoa. 2,279,788. 788. Maybe. I don't know about that. But, can we just talk about this for a second? Can we just talk about the fact that $20,000 over the course of one single lifetime turned into $2.3 million, basically? That's pretty cool. Now check it out. Look how fast it's growing. let's remind ourselves of our general equation. What's our variable? T. Where is our variable? Is it in the base or is it the exponent? It's the exponent. What type of function is that? If the variable's in the exponent, the function is an exponential function. So what do we have here? We have, it's growing with what kind of growth?
Exponential growth.
Praise God. Look, exponential growth. This is real. This is real life stuff here. We're seeing exponential growth of money. That's pretty cool. So grandma gives you that bar mitzvah check, you put it away, bam, 70 years later, you're a double millionaire. Okay, that's pretty cool, right? Yeah, that's fine. I know. Look, okay, all right, okay, so you're not saving it. Maybe you don't, but you're saving it. Say you save it to your retirement, bam, you got $589,000. That's pretty cool. Okay, and then check this out. I made this little thing, and I think that's pretty cool, so I'm going to share it with you. This is a calculator to see how long it would take you to raise $1 million based on your interest rate and how much money you have. So let's say instead of 20,000, you've got like 30,000, and say you want to have that amount in like 30 years. So like when you're 50, well, you would have to have an interest rate of 12%. So at a 12% interest rate, if you invest that money right, and you start with $30,000, 12% interest rate, you could have that $1 million pretty quick.
Yeah, but
Oh.
that's money, yeah, you can't do anything.
Yeah, but potentially, yeah, but you're saving it. That's the whole point. You're not buying the car. That's the whole point I'm making. Look, you're saving the money and you have $1 million. This is you, okay? This is you now. This is you in 37 years. I want to be there. That's great. It looks nice up there, okay? Okay, I know. Shh. So, okay, so check it out. Shh. So look, so bam, 70 years later, y'all are double millionaires, okay? So you saved the money, and look at what happened, okay? But now, let's explore the other thing, okay? Let's say, instead of saving that money, you buy the car. You're like, you know what? I'm not interested in becoming a double millionaire in my 80s. Or I'm not interested in retiring with $600,000. I just want a nice car right now. Okay? Let's say that's where we're at. Well, what do you know about cars? What happens to the value? Let's say you have a $20,000 car. It depreciates.
Exponentially.
You got like the punchline right at the beginning of the joke. Okay. All right, so listen. They depreciate, and Jacob had it right. Immediately they drop in value. But let's give it a conservative estimate here. Let's say that every year the value of your car depreciates by 10%. Okay? So the rate is 10%. Okay? Well, in this case, you don't have growth, you have decay, right? So your equation isn't 1 plus r, it's 1 minus r because you're losing value. So it's a times 1 minus r to the t, okay? So you invested that $20,000, it's losing 10% every year. Okay, well, go ahead and figure out how much will your car be worth after 10 years. Go ahead and do that now. And remember, you don't plug in 10 for r, you plug in what?
10 for T.
No. 10 for t also, but for r, it's 10%, so it would be, r isn't, it's 0.1. R is 0.1. So go ahead and figure out.
1.1%.
It's 1, no.
Just 0.1.
0.1.
One is just one not, one private.
No, because you're subtracting is 1 minus 0.1.
So because you're adding, it's going to be 1 point.
Something in general speaking, yeah.
But it doesn't really matter if you had that 1.07. It's still 0.7 and 1.0.7 both came out to be the same.
No, because you have to have the 1 in front of it. And I can show you, but if you have to have the 1.07.
So if you're going up in value, you have to have the 1. If it's subtraction, it doesn't.
Well, you're always starting with 1. It's just that you're either adding the interest rate or subtracting. So if you were adding 10%, it would be 1.1. But since you're subtracting, it's 0.9.
First example you gave, it wasn't 1.07.
Because I was just originally finding the interest, not the whole amount. Remember, I found the interest and then I simplified by making it 1.7. Does that make sense?
So it's either
Okay.
it's either got it or it doesn't.
So, okay, shh. So, let's check it out. 20,000 times 1 minus 0.1 to the 10th power. Well, what's 1 minus 0.1, class? 0.9. Okay. So, here we go. Let's give it a try. So, it's 0.9 to the 10th power. 6,974. 6,974. So, okay, that's just 10 years. You're not even on your deathbed yet. And instead of gaining money, look what just happened. Your $20,000 just turned into $7,000. And you got oil changes, and you got new tires.
I think it's still more than that.
And you got, I might have kids too. True, very true. Very good. You're thinking ahead. I like it. So the point is, guys, look, okay, you invest the money, you become a double millionaire, or you buy your nice car with your flashy rims and your new paint job, and look what happens after 10 years, you see? What is this called? It's called exponential decay. Does that make sense?
Yeah.
You guys see this?
Yeah.
Okay, and so this is how, we handle, listen to this. This is how we handle situations where we have something that's increasing in value by a certain percent every year or decreasing in value by a certain percent every year. Does that make sense? Okay, we handle it with these equations. If it's increasing, it's a times 1 plus r to the t, and if it's decreasing, it's a times 1 minus r to the t. Does that make sense to you guys? Is that pretty clear? Okay, so let's show another example of this. Let's show an example of this. A little bit different than what we spoke about. Oh, before I continue, hold on. How much save every day to be? Okay, check it out. Hold on.
Pedro, stop.
Shh. Look at this. Watch this. Guys, enough. I know. Okay. Look at this. How much do you need to save every day or every month to have $1 million by age 65? Okay? Starting at age 20, all right? But mind you, this I believe was on a 12%. It was a 12% interest rate. I think I can't.
You would
Oh.
need to earn that money.
Oh, here we go. Here you go. This is what I was looking for.
Every day.
Shh. You would need to save that money, right?
Save, earn it, and keep it.
Yeah, clearly. So look,
It's not just like
at a 7% return, at the age of 20, you only need to save less than $10 a day. Okay. All right.
But that's at 65.
I know. You all want to be millionaires now. But shh. Look at this, guys. Look at this. That's a real thing. $10 a day, that's not that hard. Okay? And 7% return, that's not that hard to find if you invest your stuff right and get a good person to help you. Okay? You could be a millionaire by 65. Look, it's not just about 65. The whole point is instead of just spending money on a new tricycle or a new baseball helmet or a new juggling something, I don't know what you guys spend your money on these days, but instead of buying a new bow tie, you have $1 million. But what is it's using your money wisely, and it's not just taking money to spend it. It's getting the blessing that God is giving you and saving it for good things, and then bam, you have set yourself up for a good life in the future. Okay, so take that all with you, and remember also what else grows exponentially. How many of you guys are going to go to college next year? Okay, what else grows exponentially? Debt. That's right. For those of you that are thinking, should I take out the 5,000? Shh. Should I take out the 5? I love you, Mr. Martinez. You guys just keep shushing you, so I just want you to know I love you. But the point is that if I have if you're debating, listen, if you're debating whether to take out $5,000 in loans, that's going to grow at not just 7%, but to grow at like 10, 12% sometimes, or get a part-time job. Do I really want to have exponential debt, right? I don't know. Maybe I'll take the part. You understand what I'm saying? You see what I'm saying? You see, this is math. This is math that empowers you in life. You see? Yes. Okay. Now, let's look at another example. Okay, and this is a less applicable example, but it is an example nonetheless. A painting is sold for $1,800, and its value increases by 11% each year after it is sold. Find the value of the painting in 30 years. Okay, it's less exciting, but it's still an example. Okay, the initial amount is $1,800. Remember my equation. First off, is that exponential growth or exponential decay?
Growth.
It's growth. It's increasing in year. Every year. So it's 1 plus r to the t. The initial amount is how much? 1,800. It increases by 11%, so it's 1 plus 0.11 to 30 years, okay? And then if we want to evaluate that, 1,800 times 1.11 to the 30th. Okay, cool. You see what I'm doing, guys? This is less exciting because it's just like a regular math problem type of thing, but you understand? This is just the process. You figure out the initial value, you figure out the rate, you figure out the time, you plug them into the equation. Is that clear? Okay. And the same is true for exponential decay. For exponential decay, an example is this, right here. Actually, we'll save that for a second. We'll go straight to your homework. We'll go straight to your homework. So what is your homework? Your homework is page 467, numbers 5 through 16. Okay? And numbers, look, everyone look up here, please. Numbers 5 through 12, they're really simple. It just gives you an initial value, it gives you a rate, and it gives you the time in years. If it's increasing, you're adding the percentage. If it's decreasing, you're subtracting the percentage. Is that clear? All right, but number 13, you're actually graphing, so I want to do that with you guys.
5 to 13?
5 to 16. Okay, so, but let's all turn to our homework, number 13, and we'll do that together. Okay, the value of a boat is depreciating. Immediately I hear depreciating. What kind of, is it growth or decay? Decay. Okay, depreciating at a rate of 7% per year. In 2004, the boat was worth $192,000. Find the value of the boat in 2013. Okay, so I know it's exponential decay, so it's a times 1 minus r to the t. What's a? What's my initial amount in this case? 192,000. Very good. What's r? It's 7% or 0.07. And what's my time? This one's not obvious, but what's my time? 9 years. 9 years. It's 2004 to 2013. 13 minus 4 is 9. So my time is 9 years. So I go ahead and I plug all those values in. And I just plug it into my calculator. I'll repeat, you guys are going to need your calculator for the next quiz. So if you don't have a scientific calculator, you need to get one. The answer is 99,919.
919.
Mm-hmm. Find the value of the boat in 2013. It's 99,919. So that's the first thing. And then the second thing, it says to graph. So I'm going to take this point, which is t is 9 years, which is here. And the value is just about 100,000, so it's about here. Okay? Now I have that point, but I also have another point immediately. What's another point that I have without even doing anything else? Yeah. At t equals 0, when no years have passed, the boat is worth 192,000. So at 0, I'm at 192,000, which is basically here. Okay? But that's clearly not enough points to make a good graph. So someone suggested another value I should plug in. T equals, what do you think? 4. Yeah, that's a good one. T equals 4. So I'll plug in t equals 4. I get 192,000 times 1 minus 0.07 is 0.93 to the 4th power. And I just evaluate that. And I get 143,626. I go ahead and plot that point. It's about right there. Oh, cool. And then you might be so inclined to just draw like a straight line, but you know it's not a straight line, right? Because it's exponential decay. So what I'd be looking to see here is that, you know, you could plug in 12 and get another point, but 143,626. But what I'm really looking for here is that you're able to say, okay, I know the shape of this function is got a curve like that. You see? Does that make sense to you guys? Is that pretty clear? Okay. All right, thank you. All right. What's that? Okay. Now, the last thing, and then you guys will have some time, bless you, to do your homework is the domain and the range. Okay? The domain and the range. So remember, the domain is the horizontal axis, the range is the vertical. So where does my graph start horizontally? Does it start at some negative number, like negative years? Where does it start? 0. It starts at 0. And what could it potentially go all the way out to? Does it ever stop? Good, thank you. Infinity. It keeps going. Okay? And the range. What's the lowest potential value of the boat? 0. But will it ever get to 0? It's an exponential function. Exponential decay, does it ever touch 0? No, remember it's got asymptotic behavior. It's got an asymptote, so it never touches 0. And what's the maximum value of the boat? 192,000. Which it does include that. Is that pretty clear, guys? Yeah? Okay, cool. All right. Nice. So, that is the lesson. What is the homework? The homework is page 467, numbers 5 through 16. Yes, sir. Yes, sir. Go right ahead. Any questions? All right, go ahead, please get started on your homework. Good job today, class.